Hey, I wanted to talk to you today about computer memory. So, we work with computers every day, and it's important, especially for programmers, to understand how they operate. And one of those things that they use to operate is memory. In programming, we deal with memory all the time, not just managing memory and taking care of objects and freeing their memory when needed, but also thinking about the size of objects, how much memory they take up. So think about where you've heard of computer memory before. So most commonplace, perhaps, is when you're talking about storage space. And we have now consumer hard drives that are on the order of terabytes. We have, it's easy to go to the store and get a 1 terabyte drive or a 2 terabyte hard drive. And that's pretty cool. Terabytes is a lot of storage. And let me see, that's a lot. And then there's other types of memory, like we deal with RAM, random access memory, a lot in computers. And your RAM affects the performance of your computer in some way. And we have gigabytes of RAM, typically. So gigabytes is another word thrown out there. And then when we go further down the scale, we have maybe some files, videos, or even some high-resolution images that are in the megabytes range. So you have megabytes. And then you have kilobytes as well. Kilobytes are smaller than megabytes, and then even smaller than that, we can keep going down to bytes. So a byte is kind of the basic unit that we talk about in programming. When you build up from there, when you put like 1,000 of them together, it's a kilobyte. And if you put 1,000,000 of them together, it's a megabyte. If you put 1,000,000,000 of them together, then you've got a gigabyte. And if you put, what is the next one? A trillion. If you put 1,000,000,000,000 of them together, it's a terabyte. So we need to understand a little bit more about what a byte is. In C#, there is actually a type that takes up 1 byte, and it's called, what a surprise, it's called a byte. So let's call this, I don't know, my byte. And so you can set this to a number, but only a certain range of values is actually going to be stored in there. So let me start it at 0, and I'm going to write a loop, and I'm going to see what I can store in this byte. Let's do a while true. It's going to be an infinite loop because true is always going to be true. And then I'm just going to print out on each line my byte, and then I'm going to increment my byte plus plus. All right, let's see what happens. Whoops, shouldn't be in quotes. That just prints out the string that has my byte in it. Okay, there we go. This is going a little fast, so I can't get much out of it. Let me close this. Alright, 0, 1, 2, 3. You can hold the enter key and we'll get through it. Hundreds, 200s, and we're back down to 0. So what this is showing me is that there's some maximum value that I can store in this byte variable, and it's 255. So it can be from 0 to 255, and that means that there are 256 different values, and there's got to be a reason for that. So the reason is when you look a little closer at how this computer memory is stored. Now, you've probably heard of computer memory described as a sequence of a bunch of ones and zeros, like a long string, a long line of these ones and zeros that somehow make up information. So that's the very same thing that's happening here. The ones and zeros are written in a different way than these numbers here. These ones are called decimal numbers. They're base 10 numbers. So we count from 0, we go up to 10, then we go up to 20, and so on. And so we have digits that go from 0 to 9, and then they go back to 0, and then up to 9 again. And they keep repeating in that way, increasing the next digit, the tens digit. So in binary, which is a very simple way to store information, we have only two values for a digit, 0 and 1. So in binary, you would start at 0, you would go to 1, and let me show you just by typing it. We'll start at 0, we go to 1, and then if you want to add 1 to 1, you would have to go to 2. But there is no way to represent 2, because you only have two different values for the digit, 0 and 1. So it's kind of like when you're at 9 and you're trying to add 1. You have to go into the next digit. So 0, 1, and then we have to go to the next digit, 1, and we'll turn this one back to 0. So it looks like a 10, but that's actually a binary 2. If you add 1 to that, 1, 1 is going to be 3. And if you add 1 to that, then it's like adding 1 to a decimal 99. The ones place becomes a 0, the tens place becomes a 0, and then the hundredths place becomes a 1. So 1, 0, 0. But because binary can only store these two different digit values, this happens a lot sooner. We only used 1, 2, 3, 4, 5 different numbers, and we're already with 3 digits. Whereas with decimal, we would count up 100 different values before we get there. So this, what looks like 100, is actually binary for 4. So we have 0, 1, 2, 3, 4. Now, binary is a base 2 system. So in mathematics, if you deal with different bases, then binary is base 2. And we work with decimal, which is base 10. And there are other ones, octal, which is base 8, that's happens sometimes in programming, and hexadecimal, which is base 16. And we do use that one quite a bit. So that one's pretty cool. So we have this byte value that can store a value from 0 to 255. And it's 255 because a byte is made up of 8 bits. Each one of these digits is a bit. So this one here, this 4, is 3 binary digits, or 3 bits. If we wanted to store bigger numbers, we'd need more bits to hold them. Since a byte happens to be 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. This would be the largest number that you can store in a single byte. 1, 1, 1, 1, 1, 1, 1, 1. And in decimal, that would be 255. If you added 1 to this, then we would try to do the same calculation as before, adding 1. So if you add 1, we'd get 0, and this next digit would add 1 and become a 0, and you would keep carrying that 1 all the way up until we were going to add another digit, right? We would add another digit, but there are only 8 bits, so we can't store that extra digit. Can't store it at all. And so we go back to 0. And this is a condition called overflow. So let me make a nice arrow. So overflow happens when you don't have enough space to store the number that you're trying to store. So in this case, we're going to overflow 255, and it's going to turn into 0. The opposite also happens. If you try to take 1 away, subtract 1 from 0, when you can only store 8 bits of information, then you're going to end up underflowing, and you're underflow to 255. It's kind of crazy, but that's what happens when you're working within constrained memory. So I've shown you byte, but we've worked with integers a lot. So integers are actually capable of storing much bigger numbers. An integer in C# is 32 bits, so that means 4 bytes, and so it's a lot bigger. Let me just see, 1, 2, 3, 4, 5, 6, 7, 8, and I'll just change it up when I get to a new byte. So that's what an integer might look like. I can't tell you which value this is in decimal without computing it. But you have 4 different bytes, and they can have all sorts of combinations of 1s and 0s to represent a pretty big range of numbers. It's a little over 4 billion different values. So that's what integers look like. Int my int. And there's actually a way to write binary in C#. So I'm going to just say 0b is how you start off a binary literal. And I'm going to type just some number, one that I can guess. Let's do a bunch of zeros and 1, 0, 0, 0. So if we follow this pattern, there's 1, there's 2, there's 4, and so we're going to expect 8 is going to be 1, 0, 0, 0, just because these are powers of 2. Everything that looks like a power of 10 in decimal is actually a power of 2 in binary. And that means you multiply by 2 to get those. So each of these digits represents another power of 2. So this would actually be a pretty big number. This one here is going to just be 8. So I'm going to delete this stuff. Console.writeLine, and I'll write out my int just to make sure of the value. There it is, 8. Excellent. So I hope that helps you a little bit understand how these things are stored in memory. Every variable takes up some space. Integers, longs, and floats, and doubles, and bytes, and booleans, they all take up a certain amount of space, and some of them might surprise you. And some of them take up a variable amount of space. That is, they can change how much space they take up. Strings in particular store a little bit of space if you have a small string, and a lot of space if you have a very big string. So those are things you have to think about. All right, I'll see you around.